This is going to be lesson 3 of our set theory unit. We're going to talk about applications of Venn diagrams. So how can we use Venn diagrams to determine a bit more about situations? How can we take some situations, express them through Venn diagrams, and use that to enhance our understanding? All those kinds of things. So the first place to start is a little bit of lingo, right? Or connecting words in set theory. So those words that are really common in describing situations and how that plays into the description, right? And application in a Venn diagram. So firstly, the word and. When I'm talking about something being part of set 1 and set 2, well, that's the intersection. Right? And we express that as A intersect B with that kind of upside down U shape. When I'm talking about something being or, right? So if I'm seeing the word or in a description at all, that means it can be in set A or set B or in both. And remember, that's what we called the union of set A and B, right? And was that U sort of shape. And then the word not. So if I'm saying something is not part of set A, then it is part of A prime, right? Or the complement. So the word not tells us that something is part of the complement of that set, right? If it's not in A, then it's in not A, right? Or A prime, or the complement of A. So let's look at our first example. So A prime here. The Venn diagram below shows the number of students who are members of student council, so set S. Right, so remember, this whole circle here is set S. Everything contained in this means that this is the number of people on student council. Y, this whole circle here is set Y. Everything contained in here means the student is part of yearbook committee. And they're part of the universal set, which is just pretty much students in student council or yearbook. So how many students are on student council? When I need to consider both of these locations, I have 12 students who are strictly in student council, and I have 3 students who are in student council and yearbook that are separate from those 12 students individually. So I have 12 plus 3. So I have 15 students on student council, or I can say that's 15 students in set S, right? The number of students in set S is both of those locations is 15 students. If I'm talking about the number of students on both student council and yearbook committee, so this and right here is what I'm looking for when I'm reading a question. That's trying to help me determine what set am I talking about, right? And remember that and means I'm talking about the intersection. This middle section here, this is S intersect Y. So I'm looking for the number of students in that section of my Venn diagram, and it looks like there's 3. So there's 3 students in set S intersect Y. Right? That's the only place of overlap. That's what that and word means. Set C, on the yearbook committee, but not on the students' council. So I'm looking for some element of prime, right? Not on the students' council. This is talking about the complement of S. But I'm looking for students who are on yearbook committee, so part of set Y. But is kind of like another way of describing and. So I'm looking for things that are on part of set Y and not on part of set S, not part of the student council. So this is another intersect, but notice I'm intersecting with a complement this time. So I'm looking for the things that are part of set Y, but not part of set S. And it's that section of set Y, excluding the overlap, right? Excluding the and segment. So it's just 7 here. So we have 7 students in set Y intersect S prime. And then lastly, on students' council or yearbook committee. So again, that or word is what I'm thinking of here. Right, this tells me I'm looking for the union. Let me get another color here to differentiate things. Let's go with this light green. Right, I'm talking about S union Y. So anything part of set S or anything part of set Y or anything in between. So it's all three of these sections here. So I have 7, or sorry, let me start from the left side. Right, those things in set S, I have 12 plus those intersects in the middle, 3 plus those 7 students just on yearbook committee. So I have 22 sets, or sorry, 22 students on set S union Y. All right, let's look at example 2. During this semester in Mr. Ha's room of 20 students, 15 students are taking math, 12 students are taking social, and 10 students are taking math and social, right? Because math and social don't need to be exclusive things. You can be in both. So let's set up our Venn diagram. I'm going to call one of these sets math. Oh, let's change that color. I'm going to call one of these sets social. Out here is the universal set of students in Mr. Ha's class. And we want to think about where these things are going to fall. So if 15 students are taking math, I know that this section here and this section here should total to 15. Right? But I don't know the breakdown yet. We haven't gotten there yet. So keeping that in mind, 12 students are taking social, right? That means this section here and this section here should total to 12. Right? But the best way to start a lot of these situations is go from the inside out. Let's start with the most specific characteristic and see where we can then place other things. And that's this last one here. 10 students are taking math and social. Right? So this is telling me that the number of students, right, the number of elements in that set math intersect social, because that and word there is 10. So I can fill that in. Now I can go back to those two previous statements. If 15 students are taking math, right, then that means there has to be 5 more students in that math set. So far I have 10 of those 15 accounted for because they're the ones that share social. But 5 of them are not accounted for. So that means 5 students are outside there in taking just math, but not social. And then on the other side of things, 12 students are taking social. While I already know 10 of them are also taking math, that means 2 of them are taking exclusively social. And then if we look back at the very top, originally it said the homeroom had 20 students. I haven't accounted for all 20 students yet. Right? I've accounted for 10 of them taking both, 5 additional students taking math, 2 additional students taking just social, which is 17 total students. So that means there's 3 left over. Right? There's 3 students in this homeroom class that aren't taking math or social. And that's what this last question is getting at. How many students are taking neither math nor social? 3 students. Right? And again, thinking about a few of these different areas, right? We have our intersection here. So this is M intersect S. Okay. Over here on the left, this would be M intersect S prime, right? Because this is just the students. Those 5 students are taking math, but not social. This here would be backwards, S intersect M prime, so social but not math. Okay. And then those 3 stragglers on the outside are not part of math or social. All right, let's look at another example. Example 3. All of the students in a homeroom class of 35 students take physics, chemistry, or both. So that's telling me that I'm not going to have anybody outside this time. This is going to be 0 because nobody should be outside of those 2 sets. But let's set it up. I have a set for physics. I have a set for chemistry. And we're going to figure out how many kids fall into each range, each set. 15 students are taking physics. Again, that's telling me that out of this whole set, right, the number should be 15. If you want to remember our notation, I could say n of p equals 15. Actually, I'll write that up here. N of p equals 15. 29 students are taking chemistry. So again, in this whole set here, all of set C, n of C is equal to 29. Notice this time, it doesn't tell us how many students are taking both. So let's see how we can address this. Well, I know there's 35 kids in the class, but if I'm thinking about these 2 situations, let's again try to figure out this intersection first, where I'm talking about P intersect C. Right now, I know that 15 students are taking physics and 29 students are taking chemistry. If I add that up, that gets me to a total of 44, right? And that's more kids than I have. So what that can tell me is if I subtract the fact that I know there's 35 students, that'll tell me how many are actually in both. It'll tell me how many students essentially I've double counted. So if I do 44 minus 35, I know there's 9 students in that overlap, right? Because the idea that I add both of these 2 things together, that's me counting every kid in physics and every kid in chemistry and every kid in both, which should be part of those first 2 groups. So that can help me figure out, okay, how much have I overcounted? If I subtract that from the true amount I know, it'll tell me how many are in that overlap. So now we can use that to our advantage. Now I know, okay, well, the number of total physics students was 15. Subtract the 9 that are also part of chemistry, tells me I'm left with 6 strictly physics students. And the number of chemistry students was 29. Subtract the 9 that also are taking physics, tells me I'm left with 20 strictly chemistry students. Okay. We can always make sure that the union C should be 35. Right, that's P or C. So 6 plus 9 plus 20 does indeed total out to 35. Right, so my strategy for this, my suggestion to you for this, is always try to start with the intersection. Right, start with the overlap. If you're not provided enough information, think about how you can find that overlap. Right, you are given the total number of that union. However, right, subtracting that total number of students total, right, gives us that overlap, that intersection there. So how many students are taking both physics and chemistry? We have 9 students. All right, your turn. Pause, give it a try. The drama production is holding auditions for an upcoming play. There's 38 students that show up to the audition. See if you can work with this information about students auditioning to play a wizard, an elf, or some background role, maybe a tree. See if you can put this information into your Venn diagram. Pause, come back when you're done, and we'll go through this. All right, let's talk about these play roles. We have wizards, we have elves, we have the set of students who auditioned. It's telling us a few things. It's telling us 27 students auditioned to play the wizard, so the set of Wizard, W, should total to 27 students. 16 auditioned to play an elf, so the set of elves, the number of students in it should be 16, right? In total for any intersections, overlaps, things like that. 8 students auditioned for neither role. Well, that's going to go out here off to the side because there's still students who showed up to the audition, but they just didn't audition for either role. So either they got too nervous, didn't audition for anything, right? Or they auditioned for something else. This is a similar situation where they tell us how many students auditioned for each set, but they don't tell us the overlap. That's going to be the place where we start, right? So to talk about wizard intersect elf, I know that in total, 27 plus 16 auditions were held. However, there is likely some overlap between students. And so that is 43 students. Okay. And then I need to subtract from that the number of students who auditioned for those two things total. And in this case, so it tells us 38 in the question, but we know 8 kids didn't audition for either of these roles. So 38 minus 8 means I had 30 total auditions for a wizard or elf. So that's what I'm going to subtract here. Right, 43 auditions happened for wizards and elves. I know that 30 students auditioned there. So what I'm left with is the overlap. I'm left with the fact that 13 students auditioned for the role of wizard and for the role of elf. Right, that can be a little tricky to think about, but I know that the total, the or, right, this 30 here is wizard union elf, right? Because this whole set can only total to 38. There was only 38 kids that showed up. And if I know 8 of them did nothing, I know 30 of them are somewhere in this set here, right? Somewhere in the union of wizards and elves. And 13 are the intersection. Now we can fill out the rest of the circles. Now I can say, all right, 27 students auditioned to play wizard, but I know that 13 of them also auditioned to play elves. So I'm left with 14 kids that strictly wanted to be a wizard. They felt that was their true calling. That was all they wanted to apply for. Elves, I know that 16 of them wanted to be elves, but 13 of them also wanted to be wizards. So there was only 3 kids, a lot fewer, who were really, really drawn to the role of elf, right? Again, in total, check it out. We need to make sure this whole thing totals to 38. 14 wizards plus 13 keeners who wanted to be both, plus 3 elves only, plus those 8 kind of nervous Nellies who didn't apply for either. This should total up to 38. 14 plus 13, 27, 330 is 38, right? Every student is accounted for and only accounted for one time. So how many students auditioned for both roles? Well, 13 students. Right, and that was this calculation up here. I knew how many total auditions took place. I subtracted the number of kids I know auditioned for one of those two roles, right? The union. And I was left over with the intersection. Let's go through another example. A group of grade 12 students were surveyed to determine which options they were currently enrolled in. The data is shown in the table below. How many students are in the universal set? So this time they're asking us, essentially, what is the sum, right? This universal outer set, how many kids fall into the union of culinary, art, or neither at all, right? Because those are the only places you can be. Either you're in culinary, you're in art, you're in both, or you're in neither. Right. So let's see. How are we going to start to fill this in? again, let's start with the most specific. So generally, that would be our intersection. We're seeing the word and. That tells me right off the bat, I have 17 students in that intersection. 17 students in culinary and art at the same time. Now that I have that, it makes it a lot easier for me to find just culinary or just art. So culinary only, right? Or again, another way to think about it, it's culinary intersect, not art, right? Culinary and not art. Well, there's 28 students in culinary only. They actually already told us that. So in this case, I need to be sure I'm thinking about what they are, how the language they're using in the question. So culinary only is telling me the strictly culinary portion. I don't need to subtract 17 from this because it's not saying culinary in general. It is saying culinary only. Art, on the other hand, doesn't say art only. So this we're assuming is the whole set of art, including that intersection. So here, where I'm looking for art and not culinary, I'm actually going to do a bit of a calculation. There's 50 students in art, but I've so far double counted those 17 that are also in culinary, so I'll subtract. So I'll be left with 33 students that are in art only. And then it tells us there's 20 students in neither, and so that goes outside, right? There's still students attending this school, they're still grade 12s, but they are not in culinary or art. So when it asks us, how many students are in the universal set? Well, I need to think about the students in any possible location. I have 28 students in culinary. I have 17 students in culinary and art. I have 33 students in only art, right? 28 in only culinary. And I have 20 that are completely outside. So if I sum all of these up, 28 and 17 and 33 and 20, right, I get 98 students. And I can say that's in set U, right? In the universal set. Because this is all of the possibilities, including none of those specific courses. All right, your turn. Giving the next one a try. The manager of the pet store kept track of the type of purchases made by 51 customers one day to collect data on how many transactions included cat products, how many included dog products, right? So 24 cat products, 21 dog products only, and then 11 cat and dog products. So think about those keywords, see if you can try to fill in this Venn diagram, pause, give it a try yourself, right? Most important thing, try it yourself, don't just follow along. And then come back and we'll see where we're at. All right, let's set up our Venn diagram. So we have our universal set, we have cat products, we have dog products. So cat products, notice it doesn't say any words like only, so that would be the entire set of cat products. Anything that's involving more than one location is probably not the place we want to start. Dog products only, right? That's telling me just about this section here, right? That's telling me about D intersect C prime, right? D dog products and not cat products. So I know that. It's just the value of one location. I don't have to worry about any calculations. I could start there if I wanted. I'm also given a very specific value for the next one, cat and dog products. So cat intersect dog is 11 in the middle here. That allows me to then figure out cat products, right? Because I knew there was 24 total. I subtract the intersection, and I'm left with 13 strictly cat product purchases. And then at the end of the day, they tell us that there was 51 customers, right? Because I want to make sure that I am really including everything. This table tells me some values, but maybe this wasn't every purchase made this day. And so let's check. 13 plus 11 plus 21 is going to be 45. which is not every purchase, right? There was 51 customers that made purchases. So, just like question B says, how many customers made purchases that did not include products for dogs? Oh, no, we're not at that question yet. Sorry, I'm still figuring out the universal set. There was 6 customers that didn't purchase something about cats or dogs. Maybe they have a bird, maybe they have a lizard, maybe they have a chinchilla. Who knows? But they didn't buy anything for cats or dogs. How many customers made purchases that did not include products for dogs? So what areas is this asking about? So this is, I'm talking about the set of D prime, right? I'm talking about the complement of D. And so what that includes is actually going to be a couple of locations. That includes these purchases that were strictly for cats, but also purchases that weren't for cats or dogs, right? Again, those birds or chinchillas or geckos or bearded lizards, whatever you're buying for. The set of D prime, right, the complement of D, is going to be 13 cat purchases, 6 neither cat or dog related purchases. So there's actually going to be 19 purchases in set D prime, right? The complement of D, not about dogs whatsoever. All right, one last example here. Out of 35 students, there are 5 students who take English and biology and 7 students who take neither. There are 3 more students taking English than there are students taking biology only. Sorry, taking English only than biology only. How many students are only taking biology? All right, this one gives us some interesting ways of giving us information. I know I'm looking at English, biology, the universal set, and I know that total, there has to be 35 students taking these classes, right? So let's start to piece this together. All right, so bear with me on this one. We're gonna do a little bit of algebra. So let's talk about our final question. Our final goal is to figure out how many students are only taking biology. So let's call this F. All right, only students taking biology is X. They tell us some other things. Let's read through the question again. So they tell us 35 students total. We've got that. There are 5 students who take English and biology. Great, we can fill that in. And 7 students who take neither of these things. So I can fill that in as well. They then tell us there are 3 more students taking English only than there are taking biology only. So if biology is X, English is X plus 3. Or English only, right? And biology only, to be specific. And theoretically, I know the total of these two things, right? I know there's 35 students total. So B only is X. E only is X plus 3. B union E is how many students? Well, there was 35 students, and I know 7 of them took neither. So B union E, sorry, that shouldn't be a U. Union E is going to be 28 students. So I know that this section here, right, let me highlight it. Get a different color highlighter. This section here, so the union of B and E, so each independent set and their overlap has to total to 28. So, using those algebra skills that I know we all have in us, these 3 sections, so E only plus E intersect B plus B only, has to total to 28. Well, E only, I had an expression for that. E only is X plus 3. The intersect, I had a value for that. E intersect B was 5. B only was X, this mathematical expression has to total to 28. And if I solve for X, what I'm solving for is biology only. So let's go through the ringer. I'm going to add my like terms. Right, I have an X plus an X, so I get 2X. I have a 3 plus a 5, so I get a plus 8 equals 28. I'm going to isolate X, so I'm going to bring that 8 to the other side, subtract 8 from both sides. I'm going to carry on over here. I have 2X, and then that's equal to 20. I divide both sides by 2, and I find out that X is 10. So the number of students taking only biology is 10. And if 3 more students were taking English only, or X has a value of 10, X plus 3 is going to be 13. All right, we can double check this. All right, again, 13 plus 5 plus 10, this should equal the 28 students who were taking at least one of these 2 classes. And 13 plus 5 plus 10 is indeed 28. 7 kids took neither, and so this works out. Right, this is pretty much as complex as the algebra is going to get, but if you're seeing phrases like a comparison where it's not telling you values, but it's telling you relationships, right? That's the whole idea of equations, is they're relations, right? 3 more students than the students taking biology, right? A comparison, a relationship without actually telling you exact values. Consider setting whatever you need to find to be the variable. So if I'm wanting to find students taking biology, let's call that X, right? Then we'll work from there. We'll look at the comparisons from there. So that's the end of lesson 3. There's practice available for you on D2L through Google Forms. We have one more lesson in our set theory unit, and then we are all done.